the Copernican Principle, the idea that the Earth occupies no preferred place in the universe.
Copernicus had a theoretical way of explaining the apparent motion of the planets across the sky. That's all it was. It wasn't a theory that told us whether or not Earth was special, or whether we played some importance in the scheme of things, or whether every place in the universe was the same as every other place. Nevertheless, this reinterpretation of Copernicus became prominent in the 20th century. It's often called the principle of mediocrity. This principle says that our location and our status are mediocre, they're unexceptional. As a result, we should not assume that we are in any way privileged, or that the universe was designed with us or beings like us in mind.
The Copernican Principle and the concept of the Earth's insignificance was popularized during the 1970s and 80s by the late astronomer Carl Sagan. In his best-selling book, Pale Blue Dot, Sagan wrote,
"Our planet is a lonely speck in the great enveloping cosmic dark."
All these factors have to be met at one place and time in the galaxy if you're going to have a planet as habitable as the Earth, which you need for complex and even technological life.
In an attempt to estimate the probability of attaining this combination of factors simultaneously, some researchers have developed equations assigning a conservative 1 in 10 value to each factor deemed necessary for advanced life.
If every element has to be there at the same time, you have to multiply the probabilities. And that's what makes the probability at the end so small. You've got 10% of this and 10% of that, and these things rapidly multiply to exceedingly small numbers. The numbers on the order of 10 to minus 15, which is 1/1000th of 1 trillion. And it's a number like that that you have to compare to the 100 billion stars that are in the galaxy. 100 billion is a very large number, but 1,000th of a trillionth is much, much smaller. On their face value, these probabilities are speaking. What they're telling us is this can't happen, or this is very unlikely to happen in the galaxy. And that's where the evidence is pushing.
And if you deny the hypothesis of cosmic design, you're basically left with two alternatives. Either that this fine-tuning is the result of physical necessity, that is to say, there's some unknown theory that will explain why these constants and quantities had to have the values they do, or else you've got to say that this just occurred by chance alone. It is the result of sheer accident. Well, that first theory doesn't seem too plausible because there just isn't any theory that would explain why all of these constants and quantities have the values they do. They appear to be just arbitrarily put in at the creation as initial conditions. With respect to the second alternative, chance, again, most theorists recognize that the odds against the universe being life-permitting are just so fantastic that chance simply cannot be faced unless you say that our universe does not represent the only roll of the dice. And so what many theorists have been driven to is multiplying our probabilistic resources by saying maybe our universe isn't the only roll of the dice. Maybe there are out there parallel, unseen, undetectable universes, and that our universe is just one in this cosmic crapshoot in which there is an infinite number of other worlds in which the cosmic constants and quantities vary randomly, and so by chance alone, somewhere in this infinite ensemble of universes, our universe would appear by chance alone, and here we are, the lucky beneficiaries and recipients of this chance hypothesis. So that in order to rescue the chance hypothesis, physicists have been driven beyond physics to metaphysics, to this extraordinary hypothesis of a world's ensemble of an infinite number of randomly ordered worlds in order to explain away this appearance of design.